And see, you got to know about center of mass of two particle system. This is the formula. Yes or no? We derived it. So let's take an example, students, to understand. Let's take an example to understand the two object system. Yes or no? So that it will be understand how we are applying it. See here, student. For example, certainly that there is a 2 kg object. Okay, there is object 2 kg, and at a distance of some distance, let there is object 5 kg. Correct. Let the distance between them is 10 meter. Yes or no? And the question is asking find location of center of mass. Find location of center of mass of the system. Center of mass of the system from 2 kg mass. From 2 kg mass. Friend, this is 2 kg, this is 5 kg, this distance is 10 meter, yes or no? So definitely the center mass will be in which side? Towards 5 kg, from the middle from 5 kg, or towards 2 kg? Definitely towards 5 kg.
C.
Okay. Center mass will be here. Yes or no? And he's asking find the distance from 2 kg. Let the distance is x. Understood, students? Go to the previous question. See here. We have taken from left side x. X is equal to how much? M2 into total distance L by M1 plus M2. Yes or no? Yes or no? See here.
Yes, sir.
We can directly find x is equal to how much? M2. M2 means क्या था? M2 into L by M1 plus M2 ना? So that is how much? 5 into 10 divided by 5 plus 2. That is how much? 50 by 7 na? Correct? Yes or no? That means, student, what I did, I found the center mass of this object with respect to this, then I found the center mass of this object with respect to this, then I added, and the addition is going to be 0. So let's apply the mass moment concept to understand. If I'll write, then I can write 2 into x minus x, because left side I've taken as negative. If left side I will take a negative, right from the reference point, this side is negative and this side is positive. Okay. Plus 5 kg into 10 minus x is going to be 0. Na? You solve for x, you will get the same thing. That is minus 2x plus 50 minus 5x is going to be 0. So 50 minus 7x is going to be 0. 7x is equal to 50. So x is going to be how much? 50 by 7 meters. Correct? If you would have asked what is the distance from 5 kg, then what you would have done? 10 minus 50 by 7. Correct? That is 20 by 7 from 5 kg. Understood or not? Let's take another example. Let's see coordinate system. Let's take so that you will understand. Let this is x axis and this is y axis. Correct? Let here at the center, at the origin, there is a 2 kg object. Right? Point mass having 2 kg object. Let at a distance, some distance, there is a point object. What is 4 kg? Correct? And the coordinate of this point is given as 4 and 3. And this angle is given 37 degree. 4 and 3 means you mean, na? That means this distance is how much? 3, na? And from this distance to this distance is how much? 4. Yes or no? He's asking find the coordinate of center of mass. Find the coordinates of center of mass. Okay, let's see, student. This is 2 kg, no doubt, and this is 4 kg. Definitely, center of mass will be towards 4 kg. Yes or no? Let this is the center of mass. Let its coordinate is going to be xc and yc. Okay, and you know, like that we just now found if this is x is equal to how much? M2 into total distance. Yes or no? M2 into total distance by M1 plus M2. Yes or no? Yes or no, student? So let this is the distance RC from this object left side. So student, RC is equal to, we can directly find RC is equal to how much? M2, sorry, that is M2 into R by M1 plus M2. That means let the total distance is R. So in total distance is going to be how much? This is 3, this is 4. 3 square plus 4 square, how much? This will be 5. This will be how much?
5.
Correct? Yes or no? This is 5 meter. That's example for 5. Then RC we can find M2 into R. That means 4 into 5 divided by how much? 4 plus 2. That is 20 by 6. That is 10 by 3 meter. Na? Understood, student?
Yes, sir.
So this RC is equal to how much? 10 by 3. That means from here, from this 2 kg, this distance is going to be how much, students? 10 by 3. So from here, this distance is going to be how much? 10 by 3 meter. Correct? If this is 10 by 3 meter, then this point, this is we have to find this coordinate. We want to find coordinate. We want to find the coordinate of this point, and this is 37 degree. Then this distance is going to be how much? Vector resolution 10 by 3 cos 37, na? And this distance is going to be how much? 10 by 3 sin 37. Correct? So if I'll go for XC is equal to how much? That is 10 by 3 cos 37. Cos 37, how much you know? 10 by 3 into 4 by 5. Correct? So that is going to be how much? 8 by 3.
8 by 3.
Then if I'll go for YC, then YC is equal to 10 by 3 sin 37. So that is equal to 10 by 3 into 3 by 5. So that is equal to 10 by 5. That is 2. The coordinate of center of mass is going to be 8 by 3, 2. That is the answer. Coordinate of the center of mass. So let's next see center of mass of a system of particle with multiple objects. We'll take a generalized formula. Yes or no? Right. Center of mass of a system of particle with multiple objects with multiple objects. Center of mass of a system of particle with multiple objects. Let's see its example. Let's take example. This is the origin. Okay. Let this is y-axis and this is x-axis. Whatever. Let there is a point mass whose mass is m1. Let there is another point mass whose mass is m2. Let there is another point mass whose mass is m3. Okay. With the position vector of this m1 is like that. I'm taking the arrow, okay, towards this direction. Position vector of m1 with respect to origin, that is r1. Correct? That is r1. Let the position vector of m3 with respect to origin, that is, let's take r3. Let's take the position vector of m2 with respect to origin. Arrow mark is in this direction. So let that is r2. Understood? And let this is the center of mass. This is the center of mass. And let the position vector of the center of mass is RC. Students, understood? Students, let I want to find the student. This is R1. This is RC. If I will find, because we want to find the mass moment of M1 with respect to center of mass. So what will be this distance, students? See, if I go for triangle law, if this one is RC, this one will be what? So that this one will be R1. This is the resultant vector. This plus this is equal to this, then this is going to be how much? R1 minus RC. Na? So this vector is definitely going to be R1 minus RC. Correct? And this vector is going to be how much? R2 minus RC. Correct? So and this vector is going to be how much? R3 minus RC. All understood this one? What is the position vector of point mass with respect to reference point? What is the distance between reference center of mass and M1? What is the distance of M2 from center of mass? What is the distance of M3 from center of mass? Okay. The student write by definition of center of mass, right? By definition of center of mass, by definition of center of mass, we can add and all addition will be 0. That means M1 into R1 minus RC, R1 minus RC plus M2 into R2 minus RC, correct? Plus M3 into R3 minus RC. This is going to be how much? 0, na? You do one thing, open the bracket and bring RC to one side, and let's it is, you will get M1 plus M2 plus M3, and you take all the negative down to that side, you will get M1 R1 plus M2 R2 plus M3 R3. Okay, we're taking 3 object system here, then we'll generalize to n number of object. Yes and no. So if I'll go for RC, then how much I will get? See here, M1 R1 vector plus M2 R2 vector plus M3 R3 vector, whole divided by M1 plus M2 plus M3. Okay, students. So we can write the generalized formula for this by taking the summation, because later on the summation is going to be integrand. Now we are using summation, later on we'll use for continuous objects integration. So that is I is equal to 1 to n mi ri, how many number of objects? If n number of objects, then n. Then that is summation of mi, only mass. That is I is equal to 1 to n. So it's understood up to this. Student, this is the generalized formula for RC. But if we'll take the coordinate system into consideration, that means here you're saying R1. Let this R1 vector, means the coordinate of this point will be given sometimes. M1 is located at xi, yi, x coordinate, y coordinate will be given. Maybe z coordinate will be given in space. M2 का coordinate, M3 का coordinate, इस तरह सारे particle का coordinate दिया होगा, तो हम कैसे निकालेंगे वहां पर? फ्रेंड, अगर मैं उसको coordinate system के साथ डील करूं, तो R1 को मैं ऐसे लिख सकता हूं x1 I cap plus y1 j cap. Okay, like that R2 के coordinate को अगर मैं represent करूं, तो मैं ऐसे लिख सकता हूं x2 I cap plus y2 j cap. Like that, so on, it will go on. Rn up to मैं लिख सकता हूं Rn जो वेक्टर है, that is equal to xn I cap plus yn j cap. इस तरह हो सकता है, 3 डायमेंशन भी हो सकता है. तो अगर हम यहाँ पर RC की बात करेंगे, तो अगर RC is equal to क्या पता चला अभी, M1 R1 वेक्टर plus M2 R2 वेक्टर dot 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 divided by number of particles M1 plus M2 plus dot dot dot, like that. So in place of R1, what I can put? X1 I cap. I can put X1 I cap plus Y1 J cap. Y1 J cap. Okay. Plus in place of R2, what I can put? X2 I cap plus Y2 J cap. Like that it will go on. And in place of M1 and M2, I will write like that, M1 plus M2 plus dot 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 dot. And this RC का भी एक coordinate होगा, that is XC I cap plus YC J cap, because अगर ये टू डायमेंशन पे है, तो उसका भी एक XC आएगा, एक YC वैल्यू आएगा. अगर मैं ये सारे XC I कंपोनेंट यहाँ पर अगर मैं इसको ब्रैकेट ओपन कर दूं, तो एक I कंपोनेंट एक जुड़ जाएंगे और सारे J कंपोनेंट जुड़ जाएंगे. तो इस तरह अगर मिला के लिखेंगे, तो ये क्या लिखा जाएगा, M1 X1 plus M2 X2 डॉट 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 डिवाइडेड बाय, सारे मास को इंक्लूड कर देते हैं, M1 plus M2 डॉट 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 होल इनटू I कैप हो जाएगा. सारे I कैप को अलग कर देंगे, प्लस सारे J कैप को भी अलग कर देंगे. दैट इज M1 Y1 plus M2 Y2 plus dot 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 divided by M1 plus M2 plus dot 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 होल इनटू J कैप. हम इस तरह लिख सकते हैं. तो अगर जनरलाइज करें इसको, तो XC को इस तरह लिख सकते हैं, XC is equal to MI XI. ओनली X कोऑर्डिनेट अगर निकालना है तो X कोऑर्डिनेट की वैल्यू लेंगे, तो I is equal to 1 to n, जितने नंबर ऑफ पार्टिकल्स है, डिवाइडेड बाय MI is equal to 1 to n. करेक्ट. लाइक दैट अगर मैं Y कोऑर्डिनेट निकालूंगा, तो क्या करूंगा मैं, जितने भी सारे M1 है उसके सारे MI YI समेशन ऑफ MI YI I is equal to 1 to n, सारे Y को जोड़ दूंगा और डिवाइडेड बाय MI, that is I is equal to 1 to n. करेक्ट। इस तरह अगर मैं ZC का वैल्यू लूं तो ZC विल बी हाउ मच, दैट इज MI ZI, I is equal to 1 to n whole divided by MI, I is equal to 1 to n। तो इसका ये मतलब है कि मुझे कोई भी अगर सिस्टम मिल गया, अगर मुझे x y z कोऑर्डिनेट कुछ भी दिया रहेगा तो मैं उसका RC निकाल सकता हूँ, और RC का XC कोऑर्डिनेट क्या होगा, YC कोऑर्डिनेट क्या होगा, और ZC कोऑर्डिनेट क्या होगा, ये भी हम समझ सकते हैं। नेक्स्ट लेक्चर में हम उसकी कुछ न्यूमेरिकल्स करते हुए समझेंगे कि कैसे निकालते हैं एक्चुअली।